Hello, I am Nikos Fotiu, and I am the CEO of Exceed. In this video, I will introduce our recent project Imperial, which stands for Improved Support for Decentralized Identifiers and Verifiable Credentials. With Imperial, we are building an access control solution for the Internet of Things by leveraging decentralized identifiers and verifiable credentials. But first, a few words about Exceed. Exceed is the first spin-off of the Athens University of Economics and Business. It was founded on July 2022 by George Polizos, Vasilios Siris, and myself. Exceed builds upon the research results of the founding team in cutting-edge domains such as next-generation Internet of Things, security, privacy, access control, as well as blockchain technologies. Exceed develops authentication and authorization systems for enterprise environments, web applications, and IoT systems. Imperial is building an access control solution for the Internet of Things by taking into consideration the security requirements of emerging IoT systems. Imperial is implementing relationship-based access control. In particular, we are using OpenFGA, which is an open source implementation of Google's Zanzibar, a relationship-based access control system used for securing Google services. Zanzibar defines two types of relationships: relationships between a user and an object, as well as relationships between objects themselves. Moreover, relationships in Zanzibar can be transitive. For example, an object may inherit the relationship of its parent. Imperial uses relationships between objects to define hierarchies. For example, in this figure, Smart Home 1 is the parent of Plug 1 and Plug 1 is the parent of Power 1. Moreover, Imperial defines access relationship between users and objects. If a user has an access relationship with an object, she can access the object itself as well as its children. For example, if user Alice has access relationship with the object Plug1, she can access Plug1, but she can also access Power1, but she cannot access Sensor1. Relationships between objects are stored in access control policy enforcement point, whereas relationships between a user and an object are issued to the users themselves. Whenever a user wishes to access a protected object, the stored and the issued relationships are combined and an access control decision is made. In order to implement relationship issuance in a secure way, we are leveraging W3C's verifiable credentials. Verifiable credentials are a W3C recommendation. In Imperial, we are using protocols currently under standardization by OpenID Foundation for managing the life cycle of verifiable credentials. Verifiable credential data model allows an issuer to attest some claims about a subject. Then, a holder, which is usually the subject itself, stores the credential in a secure enclave, usually referred to as the wallet. Then the holder can prove to a verifier that she possesses some credentials that include certain claims. In Imperial, verifiable credentials are used for storing relationships between the subject and some objects. Moreover, in Imperial, verifiable credentials are bound to a subject using decentralized identifiers. Decentralized identifiers is another W3C recommendation, which acts as a framework that enables individual DID systems, also known as DID methods. In general, a decentralized identifier is a URL, which can be resolved to a document known as the DID document. The DID document may include verification methods, such as public keys, as well as verification relationships that define how a verification method can be used, for example, for authenticating the DID owner. DID document resolution is implemented differently in its DID method. There are DID methods that require a trusted registry for storing DID documents, and there are other DID methods where DID documents are implicit. In Imperial, we are using a DID method called DID self invented by Exceed. DID documents in itself resemble to self-certified digital certificates. DID self does not require any registry, and it has the unique property that it allows multiple valid DID documents to coexist for the same decentralized identifier. This property enables, among other things, decentralized identifier delegation. In order to showcase the advantages of the considered technologies, we have implemented a demo. Our demo considers the use case of a city council that has deployed some smart cameras. These cameras can be accessed through some digital twins. The City Council has issued a verified credential to an installer company that authorizes it to access the digital twins. At some point in time, an employee of that company needs to access a digital twin. The installer company leverages the properties of the DID self-DID method to delegate its DID to Tom. Then Tom can use the issued verified credential. So let's see this in action. Okay, this is the wallet of the installer company. I will log in as the administrator. First, I will generate a DID self decentralized identifier. I will put a name and I will auto-generate the verification methods. My decentralized identifier is ready. This is the interface of the issuer of the City Council. I will issue a verified credential to the installer company. I will input its DID and I will authorize it to access camera 1. Now that the credential has been created, it can be offered to the installer company. I am redirected to the company wallets where I have logged in as administrator. I am selecting the decentralized identifier of the company, and now the credential is in the company's wallet. Now I can delegate this credential to user Tom. And I should also delegate the corresponding decentralized identifier. Now I will log out and I will log in again as Tom. I will import the delegated decentralized identifier. I will generate a new authentication key for the imported decentralized identifier, and I will also import the delegated verified credential. Now Tom can use the client application. The client application is a Python script which is used for accessing a protected resource. As you can see, I receive an authorization request. I am redirected to the wallet and I select the requested verified credential. The wallet submits a verifiable representation and the client application can access the protected resource. Now, if the City Council revoke the issued credential, access is denied.